Hello, everyone. And yeah, back in 2024, long time ago now, I was part of this really incredible opportunity to be part of a large competition. And this competition is all about synthetic biology. And I'll talk a bit more about that later. And what this competition is all about is student innovation, students coming together and coming up with creative solutions for different problems, big and small, all around the world. So our team was a very multidisciplinary team. We had lots of people in biology, people in computer science, people specializing in outreach and communication with people, as well as graphic design, as you can see by our lovely logos. Yeah, and we called our project Renewal, and the joke will make sense soon. So what is synthetic biology? I've said it a few times now. Synthetic biology is the idea of using living things, so usually bacteria, and changing something about them so they are able to do something useful for us. For example, that could mean editing a bacteria to create a useful product, a thing that people can use. And a lot of the ways that we can do synthetic biology, some very common ones involve genetic engineering, which I'll talk about soon, and things like metabolics, how these living organisms are taking in nutrients, doing chemical reactions, and making something else after. Here's a photo of some of our team. It's not the full team, it's only about maybe half of us. This was taken at the Jamboree in Paris after we had gotten a gold medal, which is a sign that we had a pretty good project. So how did we get there? First, it took a lot of planning. And here's a little schematic that kind of shows in a visual sense what our project's all about. And we'll go over it in detail. But before that, some background. What exactly was the problem that we were looking to solve? Our project kind of aligned with one of the UN Sustainable Development Goals, number 12, responsible consumption and production. And I'll talk just briefly about what that means and why it's important. So the goal of sustainable development and production is for us to give a healthier planet to future generations and maintain the beautiful things about our planet. So there are a lot of ways that we can do that. We want to protect nature, we want to reduce waste, and find solutions to make sure that we aren't polluting our world more. I'll leave you all with a brief question. When you have a piece of clothing that you really like and you can't wear it anymore, what do you do with it? And we can come back to that later. So one of the main topics that our team focused on is the issue of fast fashion. So this is where, essentially, we are buying too many clothes. A lot of people are buying way too many clothes. These clothings are usually very low quality, they are cheap, they're mass-produced. Making these clothes produces a lot of waste products, and people don't need that many clothes, so they go to waste and they enter landfills. There's an estimated 92 million tons of clothing in landfills, which that's a pretty big number. Most of these clothing is also very difficult to recycle, and only about 15%, or in some cases less, is sent for any attempt at recycling them. For the most part, they just sit there. And the fashion industry is, as you can imagine, extremely large. It's valued recently at $3 trillion, and it's increasing quite rapidly each and every year. So some more specifics on the recycling problem. Very rarely is a piece of clothing of some kind made of only one material. Usually they are a blend of materials. Usually, again, some form of cellulose, keratin, or polyesters. And they often go a lot of chemical modifications and a lot of different things that make them a lot more resistant to being recycled. When they sit in these landfills and when rainfall and other sources kind of enter into that system, they produce something called leachate. And what happens here is we have chemicals from the dyes and the modifications that are seeping into the environment. And this can cause damage to waterways, to agriculture and life, to wildlife, and those issues can even accumulate into people as well and cause health hazards and risks as well. So we identified a lot of these problems, and we all asked ourselves, what is something that we can do? What's a creative solution that can solve this problem? And that's where we came up with our solution, which we called renewal. To put it simply, we took bacteria, E. coli, and we genetically engineered it. So we changed how that E. coli works to give it the ability to break down or degrade clothes. So this is a process called enzymatic degradation. You can think of it as the bacteria. I have a little cartoon of what it kind of looks like up top and what it looks like growing on a lab plate. And basically, they have these super tiny molecular scissors that are very good at cutting into clothing, but not much else. So we'll talk a little bit about this bacteria called E. coli. Most people can't pronounce the full name. It's a species of bacteria that is very often used in labs for lots of different things. So there are a lot of lab strains, so modified, again, synthetically changed E. coli that are very useful in the lab, so they're completely harmless to people. And they can be very easily engineered or changed to do things that we want them to do. So why are we using E. coli? Why are we having them grab these little enzymatic scissors? And why are we making them break these clothings down? What are we going to do next? Part of our solution is after they break down the clothing, they're going to release different molecules that are very useful. So if you've taken some biology courses, you know that proteins are composed or made of amino acids. And keratin, which I mentioned earlier, is a part of clothing, is a protein. So if we're able to break down this protein, we can get amino acids. And if proteins are made of amino acids, that means we can take those amino acids and make new proteins. Additionally, as I mentioned earlier, cellulose is a common piece of clothing. And cellulose is made of sugars. And as we all know, sugars give you a lot of energy. Same goes for bacteria. And we can use those sugars that they make, essentially, to power new technology. So, is there a question?
Yeah. In what forms are keratin and cellulose found in clothing?
That's a great question. So, keratin itself is kind of a broad term. It's just the protein. So there's a lot of different materials that we would commonly see made of keratin. For example, wool. That's why we named our project Renewal. We're renewing the wool. For cellulose, you have things like cotton and linen as well. And there's many examples. Most clothing is made of those three materials, as I mentioned, and then turned into some other form. So we break down this clothing, the keratin, the cellulose. Okay, we have these molecules that can be used to build something, but what are we building? Here's the fun part of our project, We engineered the E. coli to know how to build spider silk. You might be asking, why spider silk? Well, spider silk is another type of protein that can be used to make a lot of different things in different fields. So we have fields in medicine, for example, drug delivery or skin grafting and repair. We have engineering and aircraft design, parachutes, the military. We have textiles, so things that people can wear. And the reason why spider silk is such a useful material and why a lot of scientists are trying to find new ways of producing it without actual spiders is it's very, very powerful. Spider silk is pound for pound stronger than steel. It's resistant to UV lights from the sun. It's resistant to fire. Very durable, very elastic, and very valuable. So how does this kind of system we designed work in the first place? Let's take this t-shirt as an example. This t-shirt, as I mentioned earlier, might be a cotton wool blend, and maybe some polyester in there as well. So as you can see, the different materials are going to be cross-linked or put into layers that are very difficult for burning or for ripping them apart or other recycling methods. Our project so far just focuses on two materials, things made of keratin and things made of cellulose. For example, again, keratin can be things like wool, felt, leather, and cellulose can be materials like cotton and linen. So here's how it works. We take our fabric blend, we get it nice and ready, and we have our E. coli ready to degrade it. Essentially, the E. coli is going to use its molecular scissors, cut it up into those useful molecules, and from there we have degraded materials. So cut up into tiny, 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 tiny bits. Very, very small. And those tiny bits are used in something called a bioreactor. A bioreactor is like, imagine a large tank full of bacteria where all the conditions are right. They have all the food, they have all the oxygen they need, they have all the things that they need to do what we want them to do. So they get to work. They've broken down our clothes, and now they're going to start producing spider silk, which we can then harvest and use. This whole process revolves around something called genetic engineering. I'm sure a lot of you are familiar with engineering, you know, building bridges, building cars, building all sorts of things that we use every day. And in biology, we can also use engineering ideas to change how the genetics of an organism works. So we can change the genes that they have. We can change how they use those genes, and they can do a lot of useful things for us. So here's a couple examples of some genetic constructs that we built. But as I mentioned at the start, iGEM is also a very multidisciplinary and diverse idea. We don't only do stuff in a lab. We also had a team of computer scientists ready to make software tools that help us out with this project. So I'll talk about it briefly. Here's a couple models that we designed for creating a software tool that any biologist can use, even if they don't know how to use computers very well. Basically, they can kind of figure out, what are the bacteria doing? Are they eating what we want them to eat? Are they making what we want them to make? And how can we optimize it or make it work even better? So there's a lot of good work done there. Additionally, there's a lot of fun stuff as well in something we called human practices, where people in our team would go around and talk to all sorts of different people, experts in different fields and genetics and clothing, as well as general public. We went to a lot of different events and even schools. So here's a few photos of us at some educational outreach events at some schools. Here's our posters for two events. One is at the TELUS World of Science in Edmonton. If you've never been there, I would recommend it. It's like a gigantic science museum right here in Edmonton. Very cool. As well as an event called K-Days, which runs every summer. So also would recommend you check out K-Days in the summer. It's an amusement park, but they have a lot of other expositions and things like that as well. Here's some photos of us in the top left here. This was at K-Days giving a tabling presentation for people who wanted to come up and learn about this problem and kind of raise some awareness. Here's a conference that we went to at the University of Calgary. And some more photos of that and some fun ones. We did some arts and crafts activities with kids to get them excited about science and kind of what science can do for the world. And we had very many interviews with different experts in different fields. So here I have a couple photos, just a few of them. We talked to experts in synthetic biology, people who know a lot about making bacteria do things that we want them to do. People who work in recycling, clothing recycling specifically, people in clothing companies, and way more. Here's a photo of me in the lab just for fun. And now you know how we went from planning to me standing in this cold room to getting a gold medal at the competition in Paris. And for a little bit of context, iGEM is a very fun and very exciting competition, and it's very, very large. It's a very big international competition, so you can see some numbers here. There are over 400 teams in our year from over 50 different countries and regions, and 4,500 or more attendees just in this year. So very cool. And here's some acknowledgements of all the different groups that helped us out. And here's a list of all the people. I don't know why the text looks weird. I didn't do that earlier, sorry. But as you can see, we had a really big team. It was aligned properly earlier. Yeah, we had a really big team of people from all different faculties and departments, as well as some really great advisors and mentors and supervisors as well who helped us out on every step of the way. So yeah, thank you for your attention, everyone. I have two little QR codes here if you'd like. The one on the left is for our website. So I mentioned earlier we had some computer scientists. We also had graphic designers, and they did a really great job teaming up to make a beautiful, stunning website if you want to check out and learn more. There's a 2025 team. There are registrations if any of you are in some related field. Although I didn't know this, I made a mistake. It's actually closing today, so maybe hurry up. Sorry about that. Yeah, thank you all for your attention. Any questions?
How far away are you from actually making these spider threads? Or estimate?
So what we've done in 2024 was all the genetic engineering. So we've created the gene constructs, and we've successfully put them in the bacteria. And we did some tests on how the bacteria react to having this extra genetic baggage. So what kind of burden that might cause the bacteria. Very preliminary stuff in terms of what it's actually going to do with the clothing. So that'll be potentially, I don't say it will be, potentially up to the next year's team, or this year's team.
When you were talking about the reactor, so you actually have constructed this kind of reactor already?
No, those are very expensive.
Okay, I have no idea.
No, it's not absolutely.
It can be minuscule, right? It can be huge. I have no idea.
No, that's actually a totally valid and very good question. I didn't mean to sound sarcastic. I apologize. We haven't quite got access to that in 2024, but we'll see where 2025 takes us.
You mentioned that you use spider silk to repair people's skin, and I actually saw some similar things in the drama. They use tilapia's skin, a kind of fish skin, to repair the patient's skin, which is burned. Is that still possible in a real surgical procedure?
Yes. So there's a lot of this background literature on there's research that's been done before on how we can use the spider silk. And so that's where we kind of started. We learned about what people have already been using it for. And so they've used it for things like skin repair surgeries or injuries in tendons and connective tissues. And so there have been applications of that in the past. The obstacle is that spider silk is hard to get. You can't farm spiders. They like to eat each other. There are labs in the US that we contacted that work on making the spider silk with bacteria. And it's a bit harder than it sounds, as you can probably imagine. It's a bit difficult to have it scaled up. So there's a lot of people want to use it, and a lot of solutions coming about on how to make it.
I'm curious about the lasting remnants of the spider silk. Does it break down, or do we take one garbage and then use it again for a little bit and have another waste product?
Great question. It depends on what you're using the spider silk for. Ideally, you wouldn't use nearly as much spider silk for most applications compared to the sheer bulk of clothing. For example, it's not going to be a very efficient process. You would be using a lot of clothing to generate a lot of these molecules to make relatively a little spider silk. But one advantage is that it is still a protein product. It is degradable. And ideally, it wouldn't be blended and chemically modified with a million different things that make it difficult to work with in the first place.
Does your process also break down clothing made out of like nylon or all different coats with the Gore-Tex protection and stuff like that?
That's a great question. For 2024, we focused on the two of the you could say, more simple materials. So keratin, just a protein. There are already enzymes that exist in nature that break down keratin. Same with cellulose. So those were a bit of an easier place to start with for the idea. But definitely with, essentially, if you can design an enzyme to break it down, then you can break it down and harvest the material. It also depends on what the thing is made of. One reason we didn't target polyester directly is what we break polyester down into isn't very useful compared to like the sugars produced from cellulose or amino acids from keratin. So certain materials might be more difficult to break down. But that is actually one advantage of our system, is that these enzymes are very selective. So these scissors are very good at cutting only one thing. So if you have a 50% wool, 50% polyester product, or cellulose and polyester product, you can remove a large amount of the cellulose and be left with just polyester, which is easier to recycle using existing methods.
Like, it's a good idea to use the bacteria, like to reduce the fast fashion, especially these days. But do you think there is another solution that community also could control for fast fashion? I'm gonna eliminate more. For example, like Shein. Shein is more common these days, more popular and cheaper than other websites. So just some influencers, they buy just from Shein to make an ad, and then they throw it. And like how you can tell the community or advise the community they can like handle the fast fashion problem.
That is a fantastic point. And I'll go back a couple slides. So when we gave lots of presentations as a team, we didn't usually talk so much, especially with the schools, with younger kids, about genetic engineering and all that. What we talked about was fast fashion and kind of educating people about it. Same with our other community involvement. So a big part of it is telling people, hey, this is a thing that's happening. It's a very trendy thing. And the more people that are aware of it, hopefully the more people might be a bit more considerate of where they're buying things from. Of course, sometimes higher quality clothes are more expensive, might be better for the environment, but harder for your wallet. So if you're able to buy higher quality clothes that aren't supporting things like Shein, which is synonymous with fast fashion at this point, essentially, fast fashion is cheaper, but it's worse for the environment. And if you're in a position where you're able to support better companies or better practices and learn about that, then that's a great place to start. And if you're not in a position to do that, another thing we talked about in our community outreach is what can you do instead of throwing away your clothes? So a problem with fast fashion is the clothes are mass produced to be cheap and they're low quality, so they break quickly. So if you're having trouble keeping your clothes lasting more than a year, what are some ways that we can recycle them on our own or reuse them, fixing them on our own, and things like that?
Yeah. In terms of quality of the clothes, you show a picture of these destroyed clothes with water. Can you still use those?
We haven't tried it yet. There would be some level of pre-treatment, so doing something to the clothes beforehand, so they probably have to be washed, they might have to be put into smaller pieces, so it is a fair limitation of our project. You can't just put anything in there. You have to do a little bit of effort first.
And since you are involved in this research and outreach, then if you don't mind, like a personal question, what do you do to on daily basis, or what kind of decisions do you make to live along the lines that you're speaking?
Absolutely, yeah. I don't buy a lot of clothes in the first place. I've had this coat for like a couple years now. It's like one of my favorite coats, so I just try to treat it nicely. But what I do is if I have something I find I don't wear very much, putting it for donation, even if it has like a small hole in it, if it's still good to go, it could still go in donation. And I haven't gotten to it yet, but it might be a good idea to learn how to sew so I can fix stuff.
We worked with a group on campus while we did iGEM too that teaches people how to mend their own clothes.
Yeah.
Do you remember what they were?
Yeah, absolutely. Yeah, we worked with a group on campus called the He Call Repair Cafe. So it's this group on campus that teaches people about how we can repair our stuff, and they have a lot of different workshops and resources. Yeah, it's HECOL.
So can you do it one more time?
Sure. Yeah,
Write it down quickly. Barb, can you write it down?
it's the He Call Repair Cafe, HECOL. I can't remember what it stands for, but something important.
Human ecology.
Human ecology. What's the COL?
That's the whole thing. It's an abbreviation of human ecology.
Oh, okay. I thought each letter was a word.
No,
I
it's
see.
the program.
Human Ecology Repair Cafe. Thank you so much. Yeah, human ecology. There we go.
Good, yes.
Never made that connection.
So I really appreciate the upcycling angle to this, but would the same technology be plausible to biodegrade faster or break down something that you could let into the landfills, like the photos that you picked or the sludge, that would do some better thing to break down enzymes that could be absorbed by the environment? Or is that a plausibility of this science, or am I out to lunch?
I think it could be plausible, but there are definitely important considerations. So, having a bioreactor in a lab is a contained setting, so that bacteria is not running anywhere. It's not going to cause any problems. But in a landfill, it's virtually impossible to control how that bacteria is going to interact or spread. And there are a lot of strict rules on putting genetically modified organisms into different environments. And I mean, it's not impossible, but it's definitely another level of consideration. It would need a lot more safety considerations. We're going to make sure these genetically modified organisms don't become as a kind of invasive species. So we need to know how they're going to interact with the microbial communities already existing, and the plants and potentially animals as well. So you don't want them to go run rampant. But if it was something to be approved, then it could definitely be a possibility. It could like speed up the natural degradation process. A lot of hands at once.
Could you use feedstocks like, say, paper or cardboard for the cellulose?
Theoretically, yes.
Would you just with all your knowledge of how the industry and all this works, I'm wondering if putting out more information and changing the mindset of the youth as to what fashion actually could be, as opposed to it having to be something new every day, like I have a different shirt on every day, and so on, because it seems to me that's what feeds it.
Yeah, absolutely. It is that kind of, there is a pressure to have something new and trendy, and something we talk about in our high school presentations especially is a lot of these things that trend for a very short amount of time. And it's all kind of to do with how these items are being marketed, and also with the low price. And that low price is due to shortcuts being taken, low quality materials, as well as very large concerns on exploited labor and outsourced in other countries. So I think this is just what I think personally. The more people we tell about how these clothings are being made, the less appealing they'll be. Because you go on Shein or on any other big company and you see a really cheap item that looks really nice and you've seen it online. That's really attention grabbing. You want to buy it.
So, as an example, a group like the Kardashians or people like that are working directly against this, essentially, by putting out all their products and stuff.
Absolutely, yeah. There's a lot of social pressure, especially with social media and trends online that promote fast fashion for sure.
Sorry, the name of the bacteria ring a bell, and I don't know if it's from my chemistry class in high school, but is it a famous bacteria? Is it a disease or something? Okay.
Oh, in terms of disease, yes, also. But with bacteria, we have species of bacteria, and within the species, there are different strains or subspecies or different ones. So E. coli is in everyone's body right now. It's everywhere. Most E. coli is completely harmless. There are a few subspecies of E. coli that are harmful, and they are like a concern for foodborne illness. And these E. coli we're using are modified to be used in the lab.
And yeah, sorry. And what was your role there? I might overheard that you're part of the psychology, biopsychology.
Yeah, that's my program. I think I forgot to mention it. So on the team, we have different sub-teams. We have a lab team. We have the website team. We have the outreach team. All these different teams. I was a student leader on the wet lab team. So I kind of did I helped organize everybody in the lab to make sure we're kind of moving on track, essentially.
Thank you very much. That was great.
Thank you.